In this video, we're going to be taking a look at dilations. Now, a dilation is when we're simply going to change its size in relation to some point. So I have this triangle here that I'm going to mark A, B, and C. And this point right here, this is going to be known as the center of dilation. And what we're going to do is we're going to dilate this just like your eye does when it comes into a bright room. So to do this, I'm going to set up these reference lines to help my dilation work as best possible. So once I have these lines, what I'm able to do is I'm able to actually transfer this triangle smaller towards the center of dilation. So I could wind up with a new AB line, A prime, B prime, and I could wind up with a new point C known as C prime. So the thing that happens about this is a smaller triangle that in every other way, all of its proportions are held, all of its angle measures are held. This is reduced by what's called a scale factor. And here we're going to call it a scale factor of 1/2 or 1:2. So what we're going to do is we're going to simply outline some of the things that the dilation does and what it does not do. This triangle has all the same angle measures as its parent triangle. So each of these angles are the same. It preserves how far the distances are in relation to each other. So if this was a side 2, then this would be half that size, so a size 1. And if this was a size 1, this would be half that size, or size 1/2, which we could call 0.5, and whatever unit of measure. It also makes sure that everything stays collinear. It stays on that same line that it was, these reference lines that I put in. It saves its orientation. It's not turning in any way or causing any kind of rotation. One of the things it does not do, however, is I cannot extend this to the other side. I can't extend it and now put this triangle over here. It does not work in that way. It doesn't dilate through, become nothing, and then become larger again. The reason for this is very simple, is if it got all the way to the point, that center of dilation, it would not preserve its angles or its betweenness of points. And the reason it wouldn't do it is all of the vertex would be located at the same point, so there would be no distances to maintain. So that's why we cannot come through. We can, however, combine transformations, but that's not what is being done here. Remember, math rocks with a capital M.